In this demonstration, the virtual machine of Windows 7 is already installed. The ransomware is right here and it's waiting to be executed. Here is the red shot. Here is the process explorer, which shows that there are only 1, 2, 3, 4, 5 processes currently running. And in the background, we've got Wireshark as well, which is running as illustrated by this one. So far it's got only DHCP and NBNS requests, which is normal for this. The DHCP requests are because it is on a local LAN segment which is not connected to the internet, and this prevents spreading of the ransomware to the internet and other computers, which is what we definitely do not want to do. Now moving on to the clone computer, which is also on the same LAN. Now to show the LAN, we just do IP config. This shows that the LAN address is 169.254.161.204. So on the clone computer, when we go to it as well, and we check the IP address, we see that it will be a different one to what we have. Let's see if we can access it. And do an IP config as well. This one has got an IP address of 169.254.62171. So they are different computers and they are on the same 169.254 network. So from the 171, I minimized that one. Here as well, the Process Explorer is running, Wireshark is running, and Redshot is running. So I go back to the original computer, which is got the 161.204, which is different from that one which ended with 171. So I'm now going to run the ransomware. Here is the WannaCry ransomware, and we'll observe together what happens. I'm going to close this window, and I'm going to minimize this one and put this one to the side. This is the secret file, which has only got the word secret. We want to see whether or not it will be encrypted by the WannaCry. So it's just here, and we opened it before. We can easily read it. We now run the ransomware. As it starts to run, we are going to be in a matter of seconds. The WannaCry shown here has already encrypted my files. And I'm already getting the oops message in the background. The desktop has already been changed, and there's the pop-up message. So within 1 minute, the files would have been encrypted and the message would have popped up. Now let's see if the file is now encrypted, the secret file. So let's try and open it. We see that we can't make sense of what's written. We know the word is secret, but it's jumbled up right now because it has now been encrypted. When we go back to the pop-up message, it informs us that payment is required in 2 days, 23, no, it's actually required in 2 hours, 23 minutes, these are minutes, these are hours, these are days. So it's required in 2 days, 23 hours, 59, which is practically speaking 3 days. And the files will be completely lost within 7 days as shown by this timer here. And it is requiring payment of $300 worth of Bitcoin to this particular Bitcoin address. And they expect that the attackers expect people to click on check payment and start going through their processes for payment by connecting to a server. But we actually are going to cancel this because we do not intend to make that payment. Now we are going to test for something. We are going to move the date to a very forward date and see what happens with these two timers. Currently it's 2 days, 23 hours and 58 minutes. So when I go and click on my date, then I change settings, and I change the date and time, change it to, let's say, to 17th. Then I click OK. Then I click OK as well. We see that automatically payment has been raised to 600 because the date now is showing that the 3 days have expired, and it's only the 7-day window period which is now only left with about 3 days which is left, but the payment has now been raised to 600 worth. So let's see what happens when we exceed even this particular time. Put it to 27th, which is even further away. Change the date, put it on 27th, and click OK. Click OK as well. Now that is got 27th, the timers no longer are counting down, but they still expect their payment because it still attempts to connect to the server. So click cancel for now. Now that we have seen how it operates and encrypts the files, we are going to go minimize these ones, minimize this one, it will keep on popping up and it becomes a nuisance. I'm going to do a second shot of red shot. Click on shot and save so that we are able to compare the changes which have been made to the Windows registry file. It takes a bit of time for it to be able to save, and then request for save, reg. Alright, we got this, reg 2, save. Let's see if we can compare these files. I doubt that we will, because I'm now assuming that the first file may have been encrypted. Wow, it actually worked because it's only checking the registry. So it's now showing us that these particular registry keys have been added under software classes, local settings, and Windows. All of these were added by the, let me maximize. These ones were added by the ransomware. So I'm going to do it. I'm going to take a screenshot of this to use as evidence. Capture screen like that. What else do we need to check? We've checked the processes. We've checked Wireshark. Let's see how Wireshark is operating on the original computer. It's showing that there are DCPv6 solicitations. Let's try and limit it to TCP. Well, that didn't work out too well. Alright, it's alright. Let's go to the clone now of Windows 7. This version must have recognized that it is operating in a virtual machine, so it did not propagate as expected this time around. But it does demonstrate the basic fact that once the ransomware runs, it demands money from the user to get the files back.